Last week, we were testing out or exploring the bounciness of 4 balls. We came up with a definition of a good bouncer. Can you read it with me? A good?
I'm teaching right now first grade. It's an inner city school, and it has a large immigrant population.
Nice job.
A lot of the children speak another language at home, and so English is their second language.
Another question that we're going to try to answer.
I just use lots of different methods to get them to understand what we're doing. I try to model the language. I try to get them to repeat after me.
How can we measure the bounciness of balls?
Today, the focus of the lesson was to have the children be able to come up with a plan for how to measure the bounciness of a ball. And they were going to use a ping pong ball and a rubber ball to do that.
Here's the question. Is the ping pong ball or the rubber ball the better bouncer?
They were to develop a fair test and think of the different variables that they would need to use to be able to do that.
So I want you to think back, and we did some tests like the fabric test, and we did the measuring the water temperature test. We were trying to make sure that we did everything in a fair way.
Fair test is a test in which all the variables are the same except one. We've done it one unit, weather unit, in the fall, and so they had a few investigations where they were actually asked to plan a fair test, and then we worked through that together and do with questioning and guiding.
We're testing out, like when we were testing the fabrics and things, we wanted to make sure that we were doing everything in a fair way. What do you think, Henry?
Don't do different things.
Okay, so do everything the same. So we're going to do that again today when we test the ping pong ball and the rubber ball to see which is the best bouncer.
They're going to encounter this as they get into 3rd and 4th and 5th grade and 2nd, and so hopefully you're laying the foundation so that at least they're familiar with the term. It's a little bit of exposing them to it and then expecting a little bit more each time you have a new investigation.
So, what could we do to make sure that the balls have a fair chance?
Measure at the same time.
Measure. Can you tell me more about that? Measure what?
Measure the balls at the same time.
What would we be doing, do you think?
A lot of it happens, with your questioning, focusing on the question that you're trying to answer.
Okay, well, measuring them doing what?
Bouncing.
So how would we get a number? We'd have to do something. How do we find it?
Counting.
Counting. We would be counting the bounces.
As we're developing this list, I'm writing it on a chart, the things that we agree upon, so that they have some place to look and check just to make sure they're all doing it the same.
Okay. What else would we want to make sure we do the same? Not now?
Bounce them the same way.
What do you mean by that?
You have to drop the ball.
Drop the ball. So drop the ball the same way?
Uh-huh.
So that's another idea.
Through the questioning, we came up with a few ideas for what should stay the same when we were doing our fair test. And one of them was that we're going to drop the ball, not throw it down. Another one was we were going to drop it from the same height.
Let's pretend that each of us had a ball in our hand and we were going to try to test it and dropping it the same way, okay? And we both stuck our hands straight out and dropped it. What do you notice here?
Your hand, it's longer, and Henry's hand, it's shorter.
Right, but even if I made it the same, but look where my hand is and look where his hand is.
As part of the engagement piece, when we were talking about how to develop a fair test, I picked a child, of course, who was shorter than I am, and we both held a ball out, and so the children could, see concretely that I was taller than he was and that the ball would have a higher place to drop from than his ball, and they figured out that that wasn't fair.
Yours is up, his is down.
Oh, mine is higher and his is lower. So this ball is dropping from a higher place and his ball is dropping from a lower place. Is that fair?
No.
No, that's not fair.
And so that started getting the conversation going, and we need to maybe start at the same place.
So what do you think we would have to do to make sure the balls get a fair chance when they're dropping? We want to drop the ball the same way, but we also want to drop it from the same place, the same height, right, the same height, okay?
And so I wanted to model trying to make it more concrete, something visual for them to see that, oh yeah, that's what it means, because height might not mean something to some of the other children until they actually see it.
Notice what happens when the ball bounces, okay? I'm just going to test this one.
Once you start modeling when you're doing certain lessons, they get the idea that, oh yeah, we need to think about all these other things.
Oh, what happens at the end?
It bounces faster.
And pretty soon, is it easy to hear the bounces anymore?
No.
And so talking through another one was we are going to count the bounces until we can't count them separately anymore.
Okay, count the bounces until they blur. That means you can't count them clearly anymore. They're all going together so fast. So we have a plan now, okay? So let's read over our FAIR test plan again. Count the bounces until they blur. Drop
It is important for them to hear it and to see it, you know, and to read it and have it posted in the room. And that's why there are a lot of charts and tables, and it's just the way I teach. I have lots of words around the room for them to refer to. When we talk about it or once they've learned it, it's there for them to use as they need it. So there's so much that happens during science and so many things that we, you know, talk about that I don't expect them to remember them. I'll just signal that that information's up there and it's a cue for them to use that.
Our ruler has how many inches? 12. And we're going to go halfway.
And then later in the lesson, I also modeled after we had developed our plan for how to run a FAIR test, because I wanted them to see what I expected them to do when they were doing it.
Right from here. So everybody's measuring from the same place, and you're going to drop your ball right from that edge.
They were to drop their ball 3 times, the same ball 3 times, and count the bounces according to the FAIR test.
Maybe got a 7 out of that one. So I had a 6, and I had a 6, and I had a 7. Pretty close, huh? Okay. I dropped it from the same height. I dropped it the same way. I counted the bounces till they blurred. I did it 3 times. I didn't write it down yet because I'm going to show you a special way that we're going to write it down. Okay, Joseph?
And then I had somebody come up and actually model going through the test.
Okay.
1, 2, 3.
Before I sent them off to do the investigation, I did have them work with me to help make a T-chart in their notebooks
Fold it to the middle.
so that they had some place to write down the number of bounces that their balls made.
If another scientist came in and opened your notebook and wanted to read about this test, they would want to know what balls you're going to be working with. Ping pong ball and rubber ball.
We talked through it so that they would understand why we were putting titles of the balls and T-charts that showed how many tries and how many bounces we would get and a place for them to put their numbers.
We have on our FAIR test plan that we are going to test the ball how many times? 3. So we're going to put on the left side of our T the word tries.
It's often, you know, typical for teachers to give the children handouts where they just fill in, but then they're not really thinking about what they're doing. I think they're maybe a little bit more engaged and tuned into what they're doing if they actually are helping make that themselves. And of course, the next time that we do it, it's much easier for them to do.
Here we go. Oh, I better start from the same place. We'll start it right from the chalk tray.
I think the reason we use all the scaffolds in science is to give them an exposure to all the different ways that information is displayed, or ways that they can use the scaffoldings to write or to think about things or to collect information on.
9 again. Okay. So when you do your tests, this is what you're going to have to do.
I don't think they're too young. I think the more you use them and the more you talk about the parts of them and show them how to read them, the easier it is for them to use. And it's also setting the expectation that I want them to start thinking and acting like scientists.
What do you think? Which one do you think will be the better bouncer?
Rubber ball.
Rubber ball. And Gabriella, why do you think rubber ball?
The questioning helps bring it out for them. Give me more information. A scientist would be really specific.
Anybody else have a prediction?
Rubber.
Rubber, because?
It bounces higher.
And how do you know it bounces higher? What have you observed?
You know, forcing them to think about what they're doing and how they can explain it, and then throwing in some of the modeling also.
Real quickly before we start, let's go over our rules for exploring ball behavior.
Then we went over the rules so that they would know what their expectations were, and that keeps a little bit of order in the room. And then we went into the investigation, them getting the materials
You need a book and a ruler and head back to your seat.
and starting the investigation of the bounces and recording the information they got.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Most of them did a really nice job of setting up the investigation and tried to think about all of the variables that they were doing.
1, 2, 3, 4.
So I think most of them were on task that way and were able to do that.
6 and 6. Oh my gosh, that's a lot of 6. How many 7s is there gonna be?
Most of them knew what to do. Most of them were really engaged. Each child had a different ball to test.
1, 2, 3.
And they were supposed to write down the numbers in their notebook. Some of them had a little bit of trouble recording some of the information. We have not done this before, and so that was a little new. And some of the children, who are a little bit younger have a lot more trouble spatially with where to put the information.
Okay, so you need to put 1.
And I think to somebody outside of the classroom it might look like a real mess, but I can usually find the information on the page. And then as you watch that child as the year progresses, or even later in the unit, you'll see a big difference.
Ping pong has had how many bounces?
10.
10 and 10, okay? And what do you notice about the rubber ball bounces?
Only have 6 and 5.
6 and 5. So according to this information, which ball seems to be the better bouncer so far?
I think ping pong ball.
Because
Because have more bounce.
it has more bounces.
I think it's important for children to have science, setting up investigations, trying things in the world and seeing how they work and collecting data. So you make time for it, and sometimes it has to be in shorter segments of time, but I think it's important to fit it in as often as you can during the week.
Okay, boys and girls, you just finished measuring the bounciness of your 2 balls by counting how many bounces they made. And you have that information on your T-charts, right? You're going to take that information and we're going to put it on a line plot graph. But what I want you to do right now is watch me, because I'm going to show you how to find the middle number of the 3 numbers that you got.
And then we figured out the middle number to each ball.
What's the highest number I have here?
7.
7. So I'm going to cross it out, just one of them. What's the lowest number?
6.
6. Okay? And so the middle number I'm going to use is 7. Okay, so you're going to take the high number, cross it out, the low number and cross it out, and the other number that's left, we're going to call it your middle number. It's the number that's kind of between, or if it's the 2 of the same number, we just take one of those numbers. All right, so here's your job. The number 1 person, take the green sticky note, write down the number you circled under ping pong balls.
And so, since there were 2 balls, I put 2 colored sticky notes on, and so each child got to write the number of bounces that one of the balls made. And then they put that on a line plot graph.
You're going to walk up here this way and place your number, your sticky note, over the number that matches the number on your sticky note.
I think it's important that when they collect data and that we're going to share it with the group, that they be able to bring some of it up to the place that it's going to be displayed.
Rubber ball people, orange sticky notes, would you come on over?
They actually see it being built and see it taking shape, and I think they had some ownership to that information because they got to put it up there, they wrote it down, they found that information out with their investigation. It's also a visual for them as a way to display information, and that's what scientists use.
You just put your sticky notes up on the line plot graph, and those sticky notes have the number of bounces that your ping pong and your rubber ball made, okay? So I want you to look at this data. How can we answer our question?
So today, before they started some of their writing, I wanted them to think like a scientist. So I asked them, why are you doing this? What are you trying to prove? Is this information helping you?
What are we looking at here on our line plot?
The bounces?
The bounces, the number of bounces. What do you notice? Here's ping pong.
So maybe trying to set them up to start thinking like scientists a little bit more.
What's the highest number up there?
10.
10. And which ball got 10 bounces?
The ping pong.
Ping pong ball did.
And I think the questioning rather than telling them so that they can come to some conclusions by themselves, perhaps.
Okay, what's the highest number for rubber ball? Keto?
8.
8. So which ball appears to be the better bouncer?
Ping pong ball.
Ping pong ball. And how do you know that?
Because the green sticky note is under 10.
Okay, so we have more green sticky notes with the number 10, and that's the highest number there.
Yeah.
So it does appear that ping pong ball is a better bouncer. So we sort of answered our question. So what we're going to do right now is we're going to try to write like a scientist to write down that information, because scientists don't just do tests and then say, okay, I'm done. They will write down what they did so that they can actually prove to somebody that, oh, this is a test I did, this is what I found out.
After the shared reflection, I wanted them to be able to write about the data that was on their line plot in a scientific way. And to do that, I wanted to scaffold it and write together as a group.
Our line plot graph tells us something. So I'm going to start our writing by telling that.
During shared writing, I'm trying to get them to think about what we just did and how to verbalize it and then put it on paper.
Shows. What does this show? What do those numbers show up there?
Bounce.
Oh, yeah. It shows how many times the balls bounce. How?
So I show them that they can take that information and I put it right into the sentence. Our line plot shows the number of bounces the balls made.
Bounce.
And then another thing that the scientist would do would tell about those numbers. What about those numbers?
10 times.
It bounced 10 times. So the next thing we're going to tell is what that ball did. The ping pong ball.
The ping pong ball bounced this many times, and so we put that information in there also.
Okay, do you think that's enough information? Or would a scientist want to know what the other ball did?
The other ball.
The other ball too, sure.
Then the rubber ball bounced only this many times.
Only bounced. How many times, Katie?
8 times.
8 times.
And then the last thing that a scientist would report would be, does that answer their question?
Is the ping pong ball or the rubber ball a better bouncer? Do we know?
Yes.
Yes, we do. And we know because
Because the ping pong ball bounced 10 times.
So they're going through the process of thinking. They're seeing me write it, so they know that their words can be put down on paper.
it bounced 10 times and rubber ball bounced 8 times.
Our line plot shows.
It's not a form of writing that they're used to doing. If we didn't go through this sharing the writing process, I don't think that they would have a very easy time or be able to write at all about what happened at this age.
Ping pong ball is a better bouncer.
You want the children to succeed, so you want to set them up to be successful. And if you need to, give them supports and scaffolding to do that you do. I think it gives them a structure.
So I'm going to take this down and I'm going to let you get started, but I will give you a teeny tiny bit of help.
So then I took that scaffolding away after we read it, and there was a frame that they could go and use to try the writing by themselves.
Our line plot shows, that means you write your words there.
This time of the year, I'm getting more children that are able to use the frame. In the fall, they weren't as able to even use the frame or to write that much. I got a meager product, and now I'm getting a lot more children who are able to get started and actually have some idea of what they want to say.
That's a good start.
And if I go around and talk with them and ask them what they're going to say next, they're definitely on track.
Mean how many times it bounced?
Okay, so you could say our line.
My observation is that as the year goes on, they don't want to stick to that frame. They want to just start writing on their own. And so they try really hard, and I think they do take a lot of pride in it.
There you go.
I don't let inaccurate spelling get in the way, and I try not to let them stop from writing. There's no reason why they can't get their ideas down on paper with the support that we give them. I'm kind of glad that I'm teaching science the last few years, because it's a great way to do that, to show that the scaffolding, it's enjoyable, and I wish I had it earlier in my career.
Okay, here we go.
I've been teaching over 30 years, but it's been helpful to me also. Things that I didn't think the children could learn, they can learn.
That's it, Keto.
Just by giving good examples and, modeling for them and
Which ball?
supporting them, they're able to do a lot more than I ever expected them to do. A little boy today in science, as he was leaving, was so excited as he was leaving. He said, "Yes, I was a scientist today."
1, 2, 3, 4, 5.
It's a very engaging subject for them.